Hey everyone, just a quick little video to show you how to add twin stick style control to a game. So that's where you can move in one direction while shooting in another. This has been used in arcades for decades. Games like Smash TV, games like Robotron, I think, was probably the first to use this. I'm not 100% certain, but it's the idea that you can move in one direction while shooting in an entirely different direction. So the challenge with trying to make this work is the fact that typically if you're doing something as far as movement or shooting, you are in some capacity using transform.forward. And that is that you are telling the object whatever direction you're facing in, move forward. Well, if you're facing one direction, but you want to move in another direction, you're not moving forward, at least not based on what the mesh looks like, okay? So like the character was moving side to side, but firing forward. So how do you do this? Well, you actually are going to have two separate objects, and therefore you have two separate forwards, and they are controlled separately. So you have a parent object. I won't call it empty because it's not quite. You've got a transform component, a collider. We really don't worry about that for this demonstration. That's for colliding with obstacles and projectiles and enemies. So we care about the rigid body and then the script. And then this is the child object. And this does not have a rigid body. That would create problems. But you have like the animator, and if you expand it out, you have like the skin mesh renderer. Don't worry about any of that. This is how it comes when you buy the asset. So depending what asset you buy, it's already going to have animations built in. The mesh renderer is already taken care of. So that's really separate. I will show you the code for calling an animation, for playing an animation, but I'm not going to show you how you build the animation. Like I said, that's just built in when you buy the resource, or if you commission a resource from someone, they'll do that for you. Okay, so what you're doing is you're separating the movement from the firing. So the parent object will handle the movement, the child object handles the shooting. So this will have a forward and this will have a forward. So this can move along its forward direction and this can fire in its forward direction. So let's take a look at the code that does that. So for the parent object, it's moveCon. So basically, and I don't know if I said it a few seconds ago, but I'm not actually using the analog control. So I'm calling it twin stick style control when in fact I'm not actually using twin sticks. I am having that core functionality of moving in one direction and shooting in another, but I'm not actually using analog sticks. You'd have to modify the code for that purposes. But the core functionality of separating movement from firing does still work. So typical WASD movement. And all you're doing when that button is pressed is you're simply changing the Euler angle. So which direction is the parent object facing? Now, a parent object, if it moves and rotates, so does the child object. So it's not that this doesn't rotate the child object, it's just that the child object will have a separate set of rotations that will override it. So the parent will have its own rotation and this will have its own rotation. So I'm not going to go through every line, but clearly you're just doing an input and you're checking for a certain key, and then you're changing the Euler angle, and you're only changing the Y because you're just rotating it on the Y coordinate, and you're not rotating it on X or Z. And as a side note, if I move this over a little bit, in the rigid body, you can see that I froze the rotation because the default physics systems that Unity uses is quirky to say the least, and you can have these weird things where something bumps and then just starts spinning crazy. So I locked the rotation so it's not rotating on X or Z. So again, this is just rinse and repeat. It's just 4 sets of checking to see a key is pressed and then changing the Euler angle based on that. Now what this does, it says if none of those keys are being pressed, see how there's an exclamation point? That means that this is not true. So this is saying if W is not pressed and S is not pressed and A and D, in other words, this checks to see if they are pressed, this checks to see if none of them are pressed. And if none of them are pressed, then 0 velocity. So you don't have to use forward here because it doesn't matter what direction it was moving in, it's not moving at all. So you don't have to do forward times 0. You can just do velocity 0. This is related to what I was just saying about rotation, about how when you bump something, it can rotate. Well, it might start rotating crazily on the y-axis. So we don't want to freeze the y-axis because we need that to do the main Euler angles, but we can override it here. If you've bumped something and your character starts spinning, this will adjust for it. Okay, so this is saying if no keys are pressed, then there's no movement and no rotation. Else, which means at least one of these are being pressed, in that case, we want to use transform.forward, and then this is just a arbitrary number. In other words, how fast or slow do you want it to move? So this is what I was talking about. This is really the key, transform.forward. You're going to see that a few times in this explanation. So if at least one key is being pressed, then move in that direction. What is that direction? The direction that was defined when the key is pressed. This takes the current Euler angle and puts it into this static variable. The reason why it's static is we'll use this basically for error correction, for want of a better term. We'll get to that in another minute. And then we don't have to talk about the two collisions because that has nothing to do with the movement. That's just checking for collisions with enemies and projectiles. So pretty straightforward. You get maybe 20 lines of code, so you're just looking to see if WASD is being pressed, set the Euler angle based on that direction, and do movement in that direction. So pretty clean, pretty simple. Now for the hero, what this does, very similar. It's looking to see if these keys are pressed. So similar to our WASD setup, this is IJKL setup. You can use whatever key you want, but I was just trying to keep it to the other side of the keyboard so as your hands aren't cramped and on top of each other. Very similar. Your character, this time the mesh, is getting its own rotation. So you can actually have a mix and match. So you can be pressing W to up and have 0, 0, 0, but you can also be pressing K, which gives you a 0, 180, 0 angle applied. So in other words, this is what I was talking about earlier. This is really the override. Okay, so it's checking to see if those 4 keys are pressed. And then, similar to what we saw with the move.com, this is checking to see if none of the keys are pressed. So if none of the keys are being pressed, we then check to see this. This is a string that we use to track whether or not we're shooting. If it's not shooting, then play the idle animation. So it's just get component, animator, play, and then the name of the animation you want it to play. And then this is an adjustment for angle. I don't want to get too much into the explanation, but bottom line is, you know how I said you could be facing one direction with the parent object, but facing in a different direction? Well, what happens is that offset will stay the same. So basically, we need to readjust this. So what's happening is we're saying if no keys are pressed, then go ahead and use the Euler angle of the parent. That way you're not walking sideways when you don't mean to, or walking backwards when you don't mean to. So if no keys are being pressed, do that. If a key is being pressed, we then check again to see if in this string variable is set to that value. If it's not, then play attack. So why are we playing attack? Because like I said, these buttons do two things. It's pointing your character in a certain direction and firing. So it's not like you have to press a button to point in a direction and then a separate button to fire. It's built in. So if you're pressing this button, you're saying fire in that direction. So if no buttons are pressed, this stuff happens. However, if a button is being pressed and you're not currently shooting, then go ahead, play the attack. The coding is identical to this. You're just playing a different value there. And this is where we set that variable to shooting. So suddenly this should now make sense to you. because up to this point you didn't see this. You just saw it being checked. This is where it gets set to shooting, is if a key is being pressed. And then it starts the shoot coroutine, and that's pretty standard. This just says go ahead and shoot the object. So instantiate the object, and then change the this value back to blank. Now, why are you waiting 3/10 of a second? It's because of the animation. So basically the character like raises its arm and then swings forward. So that was just kind of eyeballing it, saying, okay, how long does it take for the wand to the staff to be pointing forward? So that delay would be based on the animation. So you might have a character that has a bigger windup. I would not recommend it because you want this to be snappy. You'd probably want that animation to be sped up. Okay, so I think that's just about it. I really was just making this change this morning, so you still see stuff that doesn't need to be like this is here. And like I said, so it's twin stick style, although you're not actually using two analog sticks, you are still using the keyboard. So what would happen, and if you want, I could do a separate video about it, but honestly, I can't stand the new input system. I do my very best to avoid it. Um, I think it's an example where Unity makes something overly complicated when it doesn't have to. Literally 40 years ago, when I first was programming, I had a TI 994A. It literally took one command that says, take the joystick input and apply it to this sprite, and the sprite would move. So 40 years ago, using advanced basic, it could be done. And yet, for some reason, Unity can't do that now. Yes, I know things are more complicated, but the bottom line is it's still too much and it's still too complicated, and I think it needs work. I doubt it's going to happen anytime soon because this is the new version, so we're stuck with it for a while. But the good news is there are a lot of first person and third person controllers out there. I believe the Unity store has some free ones too. So, you can really get around it if you don't want to, if you don't want to deal with it. So, but that should about do it. So that shows you how to use a twin stick style. And again, the basic concept is that you're using a parent object to face and move in one direction, and that you have a child object that therefore can face in its own direction and shoot in that direction. Oh, so I do want to mention that. So we said that when you're firing, it instantiates the shot. So it instantiates the shot at the gun object position. That's actually the staff. And then transform.rotate. So that is, you're using the rotation of the object this is attached to. So once again, what direction is this object facing is basically what this is doing. This is saying what's the rotation of the object, use that object. So if I'm facing up, then this is it's going to take that object and face it upwards. And then this, when the shot is instantiated, this is the script that's on it. And we're just going to go through this one thing once again, transform.forward. So you can see the common themes, the idea of what direction an object is facing in, and then moving forward in that direction. Okay, so this is a kind of a combination of devlog and tutorial. Certainly not a step-by-step like I've done before in the past, but I've done so many of those that it becomes redundant. So anyways, I guess that's about it. So I hope you found this useful. If there's anything you'd like to see, just leave a comment, and please enjoy the rest of your day.